Welcome to BKW Physics. I'm Mr. McConley. Today we're going to do a projectile demonstration. And the point of this demonstration is to address a question I saw in the June 2012 Regents, which said, if you change the firing angle of a projectile from 45 degrees up to 60 degrees, how will that affect your distance, horizontal, the range of the projectile, and how will it affect the time of flight? Okay? And we could also say how would it affect the vertical distance. We could add another part to it if we wanted, because we'll be able to see all three of those things as we do this. So, I got this handy dandy little firing device, and what we'll do is we'll start at a real low angle, a 10-degree angle, and we'll load this thing up, and we'll fire it. Now I got three of these, so you can just kind of collect them and then bring them all back at once if you want, okay? So at 10 degrees, just kind of keep an eye where this lands. Okay? So it sort of landed right here. What would you say about the vertical height? Very, very minimal. Very minimal.
6 inches.
The distance, right there. The time. How long was it in the air for? I mean, you have nothing to compare it to, but it's pretty short, right? So now, let's creep it up to maybe, I don't know, 30. Sounds like a good angle. So we creep it up to 30. In comparison, watch this. Distance, it traveled forward. Range, what would you say? Further. Height,
Higher.
a little higher. And time of flight,
Longer.
a little bit longer. Okay. Let's come on up to 45, which by the way is a really key angle. And let's fire it at 45. So, at 45 degrees, distance,
Shorter.
A little bit farther.
a little bit farther actually, because it just went just past this line on the table, so it was a good comparison point. I know I missed the table, but that's just, I don't know, I think fire's a little crooked. Thank you. Time in the air.
Long.
A little bit longer, height a little bit higher. Okay. So now let's surpass the 45. Let's crank it right up to 60. And let's take a look at what happens at 60. Okay. Now again, it didn't hit the table, but it was coming down right about here. So you can see that the range was shorter. The time in the air was longer, and it went higher. Okay? So it's pretty clear there what's happening. And then just to confirm, let's go like a really high angle, like a 75. It might hit the ceiling, I'm not sure.
Cool.
Yep. Alright, but let me go down a little bit, because I wanted to... Let's try it again. Ooh, that's good. That's good. So you could see that at that steep angle, which is like 66 or so, you could see it went very high. So big dB. It was in this range here, so it was shorter than the 45 definitely. And the time of flight was, of all the ones we did, the longest. So generally, if we're going to look at a pattern here, because you're looking for patterns, the Regents question did not ask you for the exact answer, it asked you for the pattern. The pattern is, if we tip this all the way down to 0, like this, then the second it came out, it'd basically be hitting the table. So you got like no distance horizontal. As you increase your angle, what happens to your distance horizontal? But it kept getting bigger and bigger until we got past 45, and then what happened?
It got shorter.
And it would get shorter and shorter and shorter again until if I fired it like this, it would go up and it would come back down if it didn't hit the ceiling. So what you can say is that the two shortest distances are the two extremes, and as you hone in on 45, that's your best distance. This is why when you throw a shot put, a discus, or any baseball, whatever, anything you're trying to throw the furthest distance, you want to throw it at 45 degrees because that allows for the most horizontal distance forward. You can throw it the furthest. How about the time of flight? How did that work? Well, down here, time of flight is 0 because it's hitting the table as it's leaving. No time of flight. Bigger time of flight, bigger time of flight. Is 45 the biggest time of flight?
No.
No. In fact, the time of flight keeps getting bigger until this, if we were able to do this, it would go on, And that would be the longest time of flight. Right there, that's the longest time of flight. How about the highest flight?
90.
Again, low flight, low dV, higher, 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 higher. So that you can see that dV and the time are correlated. They both increase as your angle gets bigger. But the weird one is the dH, because
It increases a little.
it increases in the middle. It increases as you go towards the middle. So for today, projectiles.